Good morning. This is Neural Network Submission Assignment 2. The topic is image processing and computer vision using neural network. In this case, I'm using Python to implement my algorithms. In this case, basically, we will compare two models. One is artificial neural network and other is convolutional neural network. And the data set that we are using is CFAR10. So basically, I have loaded all my files here. If we can run this file. And then I load my dataset. So my xtrain and ytrain and xtest and ytest are the variables which is being loaded as the CIFAR10 dataset. Then I'll see the shape of the test. So xtest is like 10,000 images, 32 into 32 into 3. My xtrain is 50,000 images. The classes, I have like 10 classes. So my dataset is classified into 10 classes. Airplane, automobiles, bird, cat, deer, dog, frog, horse, ship, and truck. Uh, let's just plot some diagrams. So let's plot any of the diagrams. So this is with the serial number 90. Let's print some serial number 900 here. So basically, this is a truck. This is the image of a truck. This is just a sample image. That's why it's so blurry here. So if we're gonna declare some 2000 image, like I said, it's a truck again. So it has a lot of images, 50,000 images, and that to able to classify into things. So we'll normalize the data. As we know, any RBG image has like 255 range. So we'll divide it by 255 so that we get a float value or decimal value. So we normalize the data by dividing it by 255. And now we can train using our artificial neural network. So the result for I got for the artificial neural network is for the first epoch I was getting a loss of 0.3549. Over the successful epochs I got somewhat like 0.4954. So it's pretty much it's like 49% of accuracy, which is not that great, but it's all right. It's checked for convolutional neural network. So that's how you just, this is the predicted value. So just classifying the predicted value. So this is basically for the artificial neural network thing. It's a reports accuracy. We got almost 50% accuracy we are getting there. This is the convolutional neural network. So we all know how convolutional neural networks. There is a there are layers, then there max pooling, basically the smaller array which travels through the previous array and gives output to the new array. So we are gonna use 2 by 2 matrix for that thing for both the layers, and the activation function will use ReLU and softmax activation functions for the hidden layer 1 and 2 successfully, respectively. Then we have optimized it as Adam optimizer and using sparse categorical cross entropy function as the loss function. And we try to fit our CNN model to the data. So there's X train and Y train, and we're using 10 epochs, so it will iterate 10 times. We're getting accuracy over like somewhat 80%. So 80% is much better than getting 49 to 50% accuracy. So CNN is basically much better than artificial neural network. So yes, that's it. We can conclude that the convolutional neural network is better than the artificial neural network because of its model, its architecture, but still it's not effective enough to put it into realistic use because still it's just 80% and we can still do much better than this.